Einstein developed a theory about space. And it was about time too. During 1905, Einstein created the special theory of relativity, and it fundamentally changed our outlook on time and space. A long time ago, scientists believed that time and light were both absolute, under a non-observer dependent. But Einstein said that time and space were relative to observers under an inertial frame. To begin, it's important to comprehend what is relative and what is absolute. Relative is defined as in proportion to something else. To be absolute, it means to be viewed independently and not relative to anything. As the cup can be left or right, all should be able to agree to the fact the cup is full. We can conclude motion is relative as we further investigate frames of reference and their effects. For example, as you're watching this video, our frame of reference is 0 meters per second. Although, if you alter the frame of reference into respect with the sun, we are now traveling 30 kilometers per hour. Moreover, relativity continues with simultaneity. This is the relation between two events happening at the same time in the same frame of reference. Since time is no longer absolute, we assume if two events are simultaneous in one inertial frame, they will not be for another frame of reference. Graphically, as the inertial frame of reference, A, B, and C are simultaneous. But once we change the frame of reference, the events are no longer simultaneous as A precedes B and C. Furthermore, two rail cars are parallel and equal in distance and mass. By being struck by lightning, the inertial observer, represented by the star, is equal distance from both sides. This means the both strikes will be simultaneous as the light travels equal distances to get to the observer. As motion is added, the results change. In the next frame of reference, the red train moves a distance with the velocity of v. During the time it takes for the B strike to reach the observer, the train has moved right. This alters the total distance the light must travel to reach the observer. From this, we conclude that simultaneity is relative, as both observations are valid within respect to the frame of reference. Therefore, simultaneity is observer-dependent. Now let me tell you about a little boy named Albert Einstein, who never wished on a star when he was little, for he knew by the time the light reached us from the star would be non-existent. Now that's special.